Okay, so welcome everybody to this Causality seminar series. This is organized by the Institute of Data Science and Artificial Intelligence. My name is Mark Kelson, and I'm a part of the University of Exeter and a part of the Institute. The Institute is fantastic because it's interdisciplinary. You know, we have people from philosophy, social science, humanities, economics, computer science, geography, maths, computer science, computer science twice. So we have lots of people from lots of different parts of the university. This is the second week of causality seminars that we've run. And the idea is that lots of different disciplines approach causality in different ways, and we have lots that we can learn from each other. Last year, we had some fantastic speakers. Climent was presenting last year as well. And it was really fascinating to see the paradigms clashing across the different disciplines of how you might approach this broad question of inferring cause. So I'm really looking forward to this seminar series. We have today's session, then we'll have a break for a week, and then we have 5 seminars back to back on Wednesdays at 2 o'clock with a fantastic lineup of guests. And I think it's going to be a really exciting series, and we'll be recording them for hosting. We had enormous interest in this seminar series, global appeal, governmental people from at least 2 different countries, companies, academic institutes, and individuals have all expressed an interest, and we have a huge list of people who are very excited about these talks. In terms of housekeeping, there's not a huge amount, unless you're planning a fire alarm in your own house that I'm not aware of. I presume I don't need to tell you where your nearest bathroom is, so you should be all set. Grab a drink and settle back. I emailed Climent this morning with a little video clip of me pronouncing his name, and he responded with "no worries," which isn't the resounding endorsement I was hoping for. I think I've maybe not offended him too much, but I don't think I've gotten it 100% right. Nevertheless, I'm very pleased to introduce Professor Climent Quintana Domeque. He's a professor of economics at Exeter University, and I was researching him this morning. And the one thing I would say is have a look at his paper, Paving Streets for the Poor, Experimental Analysis of Infrastructure Effects. It's a really beautifully designed experimental study with impressive effects of urban infrastructure on property prices, and just a really nice, altruistic design, and it's well worth a read. Okay, I'm going to continue admitting people. In terms of questions, we've got a few people who have asked not to be recorded, so we'll reserve questions until the end. You are being recorded. Over to Climent.
Thank you, Mark, for this invitation and for the very nice presentation. Let me try and share my screen, see if this works. Let's see. Can you see my screen?
Yes, that's perfect.
Okay, so thank you so much. I'm going to talk today about why the Nobel Prize in Economics went to causal inference. So I'm an economist. I'm a professor at the University of Exeter, and I'm really happy about this Nobel Prize in Economics going to causal inference because I did my PhD in the US at Princeton University. And if I had to say in a brief of a summary where this kind of revolution about understanding causality in economics initiated, I would say that would be Princeton University and the labor section, where faculty working in labor economics and grad students doing research in labor economics are located at Princeton University. Anyway, so let me just jump into what is going to be my talk today. As you probably know, the Nobel in Economics this year was awarded to David Card at the University of California, Berkeley, Joshua Angris at Massachusetts Institute of Technology, and Guido Imbens at Stanford University. The committee awarded the Nobel for 2 main reasons. I want to emphasize the 2 main things. So the first one is that this year Nobel laureates found out a way of answering causal questions when we don't have experimental variation, where we don't have randomized controlled trials. And the idea is to use the so-called natural experiments. And these natural experiments have proved to answer very important questions in economics, but in general in social sciences. Not only that, But this year, Nobel laureates found or developed new frameworks to understand what is the effects that we are finding out with this use of natural experiments. And in particular, I'm going to try to be talking a bit about that. It's going to be the local average treatment effect. But the key idea here is to add clarity in what we can think of sometimes an obscure world. So the roadmap, if I have time, is going to be covering a few bullet points, a few ideas. So the first one is going from obscurity to clarity. And I would say like this year, Nobel's laureates, what they did is to add lots of light into this world of causal inference. The second key idea is try to understand how they try to approach the experimental ideal, thinking about randomized controlled trials as the benchmark, and how natural experiments can mimic these randomized controlled trials, which cannot be run all the time. The other important thing is the questions that they are going to be addressing, the questions that they address are important for everyone. These are questions such as, what's the impact of immigration on wages? What's the impact of minimum wage on employment? What's the impact of studying one additional year of schooling on your future income? And so on and so forth. So I want to highlight that these important questions are relevant for everyone, for private citizens, but also for policymakers. I'm going to briefly describe what do we mean exactly by natural experiment. How does a natural experiment mimics a randomized control trial? And then I'm going to focus on two of the studies that were discussed in the scientific background document of the committee. And this is one study about the impact of minimum wages on employment, and one study about the impact of education on income. These are two path-breaking studies that I want to focus in this talk. And then I'm going to be mentioning and trying to explain a bit what is the methodological contribution about understanding causal inference, and in particular, understanding what are the causal effects and for whom. And if times allow, I will show you that not only this year Nobel laureates have revolutionized the way we do research in economics, but also have revolutionized the way that we teach econometrics. Okay, so let me start with two kind of like quotes. So the first one, you can see it from Ed Lamer paper in 1983, and it's quite shocking. It says, there are two things you are better off not watching in the making, sausages and econometric estimates. And I want to go like 30 years later, and typically one of the questions that you are expected to answer when having a discussion about an empirical paper is, what is your identification strategy? This is kind of the identification strategy concept is one that was popularized by Alan Kruger and Josh Angrist in a chapter of the Handbook of Labor Economics that, if I remember correctly, was published in 1999. But the main idea here is that essentially what's going to happen is like this revolution brought us from a place where basically people were very concerned about the way empirical research was being done. In particular, very people were afraid about empirical studies, were not very convinced about what these results meant. And we moved to a world in which essentially doing empirical research is something really important and something valued by the profession. So the idea here is that in the late 70s and in the beginning of the 80s, there were lots of concerns about the way that inference, causal inference, was being performed. These concerns were highlighted by several researchers. One of them was Orgel and Felter, also Ed Lamer that I was citing before, David Henry, Chris Sims, and others. Just as a matter of summary, I would like to highlight the bullet points here. So the first one is like Lalonde was a student of Orgel and Felter and David Card, ran a study in which basically what he did was to compare observational estimates against experimental estimates. And surprise, surprise, the idea was that, or the main result was that essentially it was very difficult to replicate the experimental estimates using only observational variation. Okay, so this was quite shocking because essentially the idea was, well, if we do not understand, we don't have a clear understanding where variation comes from, it's not clear that we're going to be able to use observational data to replicate experimental findings. At the same time, there was kind of review by Greg Lewis showing that, if anything, OLS were more credible, OLS estimates were more credible than IV and selection approaches. And the main concern here was that most of the time, researchers were using IV and selection approaches without carefully thinking about the identifying assumptions. What were the assumptions? What these assumptions actually meant? So basically, they were just using some techniques, but without a clear, proper discussion of why these assumptions should be true or not. And the other important thing to keep in mind is that this was in a context in which replicability of published results was something very difficult. So many studies were not being able to be replicated, and some researchers were not making available their data sets or codes or things like that. So that was the scenario. And so in this context, Orlish and Felder was one of the most important persons in pushing this agenda for using RCTs, randomized control trials, in particular in training programs. And the main problem in training programs was that there was selection bias. People participating in job training programs tend to be different than people not participating in job training programs. So in an ideal experiment, the treatment is randomly assigned, and hence we expect that the treatment and control groups to be similar in the absence of treatment. So average differences in their outcomes after random assignment are expected to be to reflect only the treatment effect. And indeed, the 2019 Economics Nobel awarded to Abid Banerjee, Esther Duflo, and Michael Kremer celebrated the rise of RCTs in economics and their role in alleviating global poverty. Now, as I said before, experiments are not always feasible or ethical. And so what can we do? Well, in particular, we may be interested in questions such as, will raising the minimum wage increase unemployment? Will studying more increase my income later in life? These are, of course, very important questions, but it's not conceivable to think about running an experiment in which minimum wage is different or varies experimentally across individuals conducting the same job. That would not be ethical. And similarly, it's very difficult to come up with a study in which you increase or you force people to study more or to study less. So to answer these questions, David Card, Josh Angrist, and Guido Imbens, together with the late Alan Kruger, developed the use of natural experiments. And this is not something like, if you think about it, it's not the natural experiments were something quite new. What it was new is like its use or making use of natural experiments to use existing methods in economics. A natural experiment is basically something that tries to mimic a randomized control trial. The main idea is that we are focusing on the design of the study. We want to understand what is the source of variation in the treatment that we are interested in. In particular, we can think of a natural experiment as a study design in which the units of analysis, for instance, people, are exposed to as good as random variation caused by nature. One could think of things like season of birth or quarter of birth or date of birth. Institutions, for instance, there could be a rule saying that in order to be admitted to a certain school, you need to get a score of 89. And if you score just below 89, you don't make it. And of course, you can think about comparing individuals just and below the threshold, such as thinking that this is as good as random variation, or policy changes. For instance, it could be that one region or one state increases the minimum wage, but not the other, and maybe this can be used as a natural experiment. And indeed, one of the key path-breaking studies cited in the scientific background document is the paper that Alan Kruger and David Carr did on the impact of minimum wage on employment. And this was motivated because theory, as many times, is not giving us a clear answer in the sense that different theories predict different things. If we believe that labor market is a competitive thing, so that essentially employers take wages as given, we expect that an increase in the minimum wage will reduce employment. And this is what typically is taught in Economics 101. Of course, labor markets need not be competitive. And if labor markets are not competitive, for instance, when we have a monopsony, when essentially the employer has some market power, what's going to happen then is a bit different. Essentially, in a monopsony, what's happening is that the employer is hiring a lower amount of workers in comparison to the competitive market and paying a smaller wage. So in that case, a small increase in the minimum wage will actually increase employment. So what David Carr and Alan Kruger decided is to test whether employers' behavior was wage taking, thinking in a competitive market, or wage setting. They had some market power. And indeed, what they did was to, they realized that an impending increase in the minimum wage in New Jersey provided the opportunity for a prospective quasi-experimental study. And this was prospective because they knew that the minimum wage would increase, and so they could try to run a survey before and a survey after the increase in the minimum wage. So briefly, the treatment group was a group of restaurants in New Jersey, and the control group was a group of restaurants in Pennsylvania. This is a natural experiment, and they tried to design it such that it mimicked a classic randomized control trial. As I was saying, they conducted a survey before and after, and this was a good thing because somehow they tied up their hands. So once the survey was done, it was done. You cannot change the type of questions that you ask. And so essentially what they did was to use a difference in difference approach to measure the causal effect of minimum wage on employment. What we have in this table here is just like a summary based on table 3 from David Carr and Alan Kruger paper. So essentially we have the employment in Pennsylvania and New Jersey, and we have data before and after the increase in the minimum wage. So the increase happened in New Jersey, not in Pennsylvania. And so what we can see, first of all, is that before the increase in the minimum wage, the employment rate was higher in Pennsylvania than in New Jersey. And after, what we can see is like it decreased a bit in Pennsylvania, and actually it increased a bit in New Jersey. So the first reaction to this table is to say, well, if anything, it seems like the minimum wage is not reducing employment. If anything, it's increasing it. So let's try to think about what is exactly going on this table. So the first thing is that actually here we can compute two differences, and that's the origin of differences in differences. So essentially we can compute the difference in employment before the increase in the minimum wage. And what we can see is like there is a difference of 2.9 percentage points. So employment was lower in New Jersey than Pennsylvania. But after the increase in the minimum wage, this reduction actually decreases to minus 0.2. And actually, if we take minus 0.2 minus 2.9, what we get is 2.7. So indeed, what we are trying to find out here is what's the impact of the minimum wage on employment in New Jersey. And it seems like, if anything, what we observe is an increase in employment, not a decrease. Now, is this capturing a causal effect? Well, the assumption to think of this as a causal effect, as recovering a causal effect, is what is called parallel trends. So essentially, this assumption means that the difference in employment between Pennsylvania and New Jersey would remain constant had not been a change in the minimum wage. So the assumption boils down to say that 23.3 minus 20.4, which is the difference before the experiment, before the policy changed, is the same after if there is no increase in the minimum wage. Of course, we do not know what is the employment in New Jersey after the increase in the minimum wage if there is no increase in the minimum wage. That's the CF thing, that's the counterfactual. But the assumption is that these two things are equal, and so we can back out what is this counterfactual. This counterfactual would be 18.3. And indeed, if we subtract 21, which is the employment rate after the increase in the minimum wage in New Jersey, minus this 18.3, which would have been the employment rate in New Jersey without the increase in the minimum wage, what we get is this 2.7. So essentially, what this method boils down is to assume that if we have parallel trends, somehow we can find out what would be the counterfactual for New Jersey, and then try to find out what is the causal effect of increasing the minimum wage on New Jersey. Now, graphically, we can think that we start from this bullet point here in dark black here. This is Pennsylvania, and then this is New Jersey, and this is before the increase in the minimum wage. Then we have Pennsylvania after the increase in the minimum wage in New Jersey, and New Jersey after the increase in the minimum wage in New Jersey. So we see a reduction in employment in Pennsylvania, we see an increase in employment in New Jersey. And essentially, the red dot here is the counterfactual. And this counterfactual is obtained by assuming that there are parallel trends, that the evolution of employment rates in both Pennsylvania and New Jersey would have been parallel had the minimum wage remained the same. Okay, that's the main identifying assumption. Okay, so again, the way to think about that is that the difference before would be 20.4 minus 23.3, so that would be minus 2.9. The difference after would be 21 minus 21.2, would be minus 0.2, and the diff in diff would be this minus this, and this minus this, and that would be minus 0.2 minus 2.9. This is a 2.7. Of course, you can also compute this change by backing out what is the counterfactual. And the counterfactual, as I said before, can be obtained by assuming parallel trends, which is indeed what diff in diff is doing, right? So if we assume that trends are parallel, the counterfactual is 18.3. That's the number that we get from here, okay? And so we can then get that 21.2 minus 18.3 is what? Is the 2.7. So this is the causal effect of increasing the minimum wage on employment in New Jersey. If we believe that the only change in after the increase in the minimum wage is the minimum wage. There is nothing else affecting New Jersey other than the reform in the minimum wage. Okay. Now, the role of difference in economics has been quite amazing. So this is a figure from a recent work by Janet Curry, Climent, and Sears. And what we can see here, this is a plot of the working paper series. This is like the main working paper series in economics, and also the papers published in top 5 journals. So these are the JPE, Econometrica, AER, Review of Economic Studies, and the Quarterly Journal of Economics. And what we can see is something quite fascinating. So in the 80s, essentially, the fraction of papers in applied microeconomics doing diff in diff was essentially 0. Nowadays, it's about 25%. Okay, and if we look at 1994, when this article about the minimum wage and employment was published, they were also like less than 5%. Okay, so the impact in the profession of this type of research has been amazing. And the difference in differences is kind of like one of the main tools in the economist toolbox, and it's something that actually it's a very, very important active area of research, because of course what I was mentioning before is a case in which we have just one policy change and 2 states. You can imagine a situation in which we have 50 states and multiple policy changes over time, so things become a bit more complicated in that case, and actually there are several people working on that. Anyway, so this is the first question I wanted to talk about. So basically, the impact of the minimum wage on employment, and how a very clear design allows us to think about the causal effect, as long as we assume that the parallel trends assumption is a reasonable assumption. Now, the next question I wanted to discuss, and this is also, again, a question for everyone, is the one on education and earnings. And this basically boils down to say something like, should I study more? And in particular, what will my earnings be if I study more? Let's think about a causal model linking education. We're going to call education S. We can think as S as a continuous variable, let's say years of schooling, or a high school indicator. In that case, would be a binary variable, and earnings given by Y. And this is given by this linear model, which earnings equals alpha plus beta high school plus an unobservable, which captures any other determinants of earnings. This could be ability, this could be like family resources, whatever. Graphically, we can think of this simple model as something saying, well, education and earnings can be related. And of course, it could be like education is causing earnings, but it also could be like individuals who anticipate they're going to have higher earnings decide to study more. And in that case, we will have reverse causality. Or it could just be that individuals who are more talented decide to study more, and they also are they also earn higher earnings. And of course, if that's the case, well, if we try to understand what's the relationship between education and earnings without accounting for these unobservables, what's going to happen is that we're going to have an omitted variable bias. So essentially, if we think about the OLS estimate, the covariance between earnings and education divided by the variance of education, this is not going to be beta, but it's going to be beta plus this factor here, which captures the relationship between unobservable things and schooling. Okay, that's the main issue here. So beta OLS is going to be different than beta. Angrist and Kruger in 1991 proposed to use instrumental variables approach to solve this problem, inspired by sort of a natural experiment. And this natural experiment, if we think about it, is given by quarter of birth. Okay, so the idea here is to use quarter of birth as an instrumental variable. So first of all, let me just graphically try to think about this problem. So essentially, they think about the previous figure, education, earnings, and the unobservables, and they think, well, maybe quarter of birth has an impact on education. And of course, the first thing that we need to understand when looking at this graph is why quarter of birth should be related to an education. The story here is the following. Quarter of birth is relevant for education in the US for at least two different reasons. The first one is like the school starts once a year, let's say when a child turns 6. At the same time, individuals are allowed to leave school at a certain age, let's say the day a student turns 18. Now, suppose you want to compare two individuals born a day apart. So one individual was born on December 31st, the other one was born the 1st of January. In that case, both children start school on the same date. Remember, we can think of September 1st, first day of school. And what's going to happen is that at this date, the December born child is going to be 5 years and 8 months, while the January born child is going to be 6 years and 8 months. Now, the point here is that if both want to drop out of school, only the January born child can do so prior to the end of completing high school. And that's the power of quarter of birth in this context. So quarter of birth interacting with both the age at which students can drop out of school and the age at which students start school generates this sort of variation in schooling, depending on whether you are born early in the year or late in the year. And so essentially what's happening is that indeed quarter of birth is going to be related to education because individuals born at the end of the year are more likely to finish high school, while individuals born early in the year are less likely to finish high school. So in other words, we can think that the covariance between Z, the quarter of birth, and S, schooling, is different than 0. Now, on top of that, one may argue that date of birth is random, okay? Whether you are born on the 31st of December or January 1st is random. This is a point I'm going to get back later. But let's assume that this is random. When we think about this being random, you may think, well, maybe if quarter of birth is random, then quarter of birth somehow is going to be unrelated with these unobservables. Remember, these unobservables can be ability or being talented or being very hardworking or whatever. And so then we think, well, if we know that quarter of birth affects education and quarter of birth is as good as random, well, then maybe we can use IB. The idea here is that this is the kind of like the general presentation of IB. We have two conditions, the relevance condition, quarter of birth affects education, and the exogeneity condition, quarter of birth is unrelated to these unobservables. And we know that then in that case, the IB estimate, which is the covariance of earnings with quarter of birth divided by the covariance of earnings with, by the covariance of education with quarter of birth is going to be equal to beta. Okay, that would be the case if these two conditions hold. Now, this seems quite reasonable. And indeed, if we look at the graphical analysis presented in the paper by Angrist and Kruger and summarized in the scientific background of the committee, the Nobel Committee, what we can see is like this first figure here, which plots years of schooling by year and quarter of birth. And what we can see, first of all, is that there is a kind of gradient. So individuals that are born later tend to later in terms of like year of birth, tend to have more education because education was increasing between the 30s and the 1939s. But at the same time, and more importantly for the story of the instrumental variable, is that individuals born late in the year tend to be, on average, more educated than individuals born early in the year. So you can see like there are lots of like 4s and 3s at the top and 1s and 2s at the bottom. So meaning the average years of schooling is higher among individuals born in quarters 3 and 4 than among individuals born in quarters 1 and 2. Indeed, this is telling us that there is a relationship between the covariance between S and Z. So the covariance between S and Z is different than 0. At the same time, if we plot the log weekly earnings on year and quarter of birth, what we can see also is that individuals that are born late in the year tend to have higher weekly earnings. Okay, so again, the same pattern arises. So we have that 4s and 3s tend to be at the top and 1s and 2s tend to be at the bottom. So going back to the point, this essentially means that the covariance between income and quarter of birth is positive. Okay, so this bottom part here is positive, and so the ratio between these two things, is going to be the IB estimate. Okay. Now, so far so good. Now the question is, going back to the previous expression, what are these unobservable factors? So what are these factors included in U? So they can include potential determinants of quarter of birth. We can think that family background, things like parental education, parental income, can be related to when an individual is born in the year. So for instance, maybe teachers prefer to have children in spring, and maybe other type of occupations prefer to have children other parts of the year. And indeed, there are some studies looking into the demand for season of birth. But this is the effect of quarter of birth, or the determinants of quarter of birth. What about the effects of quarter of birth? In other words, can we think of alternative channels by which quarter of birth affects earnings? And this is something that arises when we have relative age effects. So we can think, for instance, that physical development or emotional development, it's going to depend a lot when you are a child, if you are born, let's say in January, in December. So 1 year difference at this stage can be quite a big difference. This can be important for physical development, in particular for sports, but it can be also important for emotional development. Now, I want to go back to the previous figure that I presented and think a bit different in terms of U. So now what we have here is not U, but we can have something like a sports and family background. And family background and sports are affecting education and earnings. And then the question becomes, does family background affect quarter of birth? First question. And does quarter of birth affects sports? Actually, we can try to think about this in terms of covariances in a linear world. And essentially what we would like here is that the covariance between quarter of birth and family background is 0. So there is no link between family background and quarter of birth. And we also want that there is no link between quarter of birth and sports. So the covariance between Z and sports is 0. This is very important. And this clarifies something that in the standard IB approach, the classical IB approach in economics, until the work by Imbens and Angrist, was not so clear. And this is the fact that here, actually, we have three conditions. The first one is independence. We want quarter of birth to be as good as randomly assigned. And indeed, if quarter of birth is as good as randomly assigned, there's not going to be any relationship between family background and quarter of birth. But this doesn't preclude the possibility that quarter of birth has an impact on earnings via something else different than education. If quarter of birth has an impact via relative age effects, the exclusion restriction can be violated. And this is A3 here. And indeed, clarifying IB assumptions is a central development made by Josh Angrist and Guido Imbens in their paper on the local average treatment effect. So let me now move to this bit. So I'm going to introduce a bit of notation here. So suppose that our interest is on the effect of completing high school on earnings. Y is the earnings of individual, S equals 1 if the individual completes high school, S equals 0 if the individual doesn't complete high school. Y1 is the earnings of individual if completing high school. Y0 is the earnings of individual if not completing high school. Z equals 1 is the individual, Z equals 1 if the individual was born July, December, late in the year, and 0 if born early in the year. And so the causal effect for individual I is just the difference between Y1 and Y0. Of course, we can never observe Y1 and Y0 for the same individual at the same time. So at most, what we are going to be able to learn is about the average causal effect. So how do Angrist and Imbens clarify the IB assumptions? So the independence assumption tells us that Z is independent of potential earnings and potential high school completion status. So essentially, this is the independence assumption. The relevance assumption is that indeed being born late in the year is going to affect the likelihood of completing high school. And the exclusion restriction is specifying that the impact of being born late in the year on earnings only comes through the likelihood of completing high school. Okay, so these are the three assumptions that we need. Again, independence is going to give us two main things. Independence is going to give us, on one hand, that we are able to find out what is the causal effect of instrument on the outcome. This is what we call the reduced form or the intention to treat. And this can be obtained as the regression of earnings on quarter of birth. And we can also find what is the causal effect of the instrument, quarter of birth, on treatment, high school completion. That's what we call first stage. And this is just obtained by running a regression of high completion status on quarter of birth. Now, if this second effect is different than 0, what we have is that the instrument affects the treatment. So the relevance condition holds. So indeed, those born late in the year are more likely to complete high school. And the final assumption, remember, is the exclusion restriction. We want that the only channel by which the instrument affects the outcome is the treatment of interest. The only channel by which being born late in the year affects earnings is by a completion, different completion of high school. Now, this is a clarification about what is behind this covariance of Z and U equals 0. So assumption 1, independence, and assumption 3, exclusion restriction, imply this sort of exogeneity, this covariance between Z and U being 0. But there is something else, and this is quite important. So far, we haven't talked about different causal effects across different individuals. And the question is, are causal effects the same for everyone? In general, we're going to have different causal effects for different individuals. Moreover, not everyone's education will be responsive to quarter of birth. Not everyone's treatment will be responsive to the instrument. This is the other important point made by Imbens and Angrist, and which is going to be crucial in trying to understand what is the causal effect that we're identifying. We can indeed think about 4 different populations. On one hand, we have always takers. These are individuals who complete high school regardless of when they were born. There are never takers. These are individuals who drop out of high school regardless of when they were born. There are compliers. These are individuals that complete high school because they were born late in the year. So essentially, these individuals do what the instrument tells them to do. And finally, we have this last group called the fires, which these are individuals who are going to drop out high school because they were born early in the year. So they do the opposite of what the instrument tells them to do. Okay. Imbens and Angrist adds a 4th assumption here called monotonicity, which essentially what it does is to say, well, maybe some individuals are not affected by quarter of birth. So maybe their educational decision does not depend on quarter of birth. But among individuals whose decision of studying more depends on quarter of birth, the direction of the effect is going to be the same. They are pushed in the same direction. And this is specified as saying that the potential educational attainment when born late in the year is at least as high as the potential educational attainment as born early in the year for all individuals. Again, the idea of monotonicity is to rule out the possibility of having defiers, individuals doing the opposite of what compliers do. So while the instrument may or may not affect an individual, all individuals affected are pushed in the same direction. And so the paper by Guido Imbens and George Anglis in 1994 essentially tells us that the IB estimate, which remember is just given by the covariance between Y and Z divided by the covariance of S and Z, so the covariance between income and quarter of birth divided by the covariance between schooling and quarter of birth, which in the case that Z is binary 1-0, because this is what? This is being born late in the year, and this is being born early in the year. So this is average earnings among those born late in the year minus average earnings among those born early in the year, divided by what? Divided by average schooling among those born late in the year minus average schooling among those born late in the year, early in the year, sorry. This is what? This is, given that if we think about schooling as a binary indicator, that's going to be, in that case, the fraction of high school individuals among those born late in the year. This is going to be the fraction of individuals with high school education among those born early in the year. So this is something that it's always true in that case. But what they show is that under assumptions 1 to 4, then the beta IB, the IB estimate is what? Well, it's a causal effect, but what sort of causal effect? It's a causal effect. It's the difference in earnings among the difference in earnings, like when you have high school and when you don't have high school. It's an average. So this is an average causal effect among those individuals who are pushed to study or to complete high school because they were born late in the year. And that's the condition here. Okay. So under assumptions 1 to 4, the IB identifies the average causal effect for the population that changed their treatment status because of the value of the instrument. This is the average causal effect of high school completion amongst those who complete high school because they were born late in the year. Okay. This is called the local average treatment effect, or also it's called the complier average causal effect. So essentially, what this paper by Guido Imbens and George Anglis does is to link two different frameworks. On one hand, we have the economics IB framework, in which we have exogeneity and relevance. And on the other hand, we have the potential outcomes framework by Neyman and Rubin, which was, so until that date, linked to what? Linked to experiments and linked to the propensity score. They link it to natural experiments by thinking about instrumental variables. That's the main insight, unifying these two different frameworks. Now, is this important? Well, as you can see, identification in economics, this comes again from the paper by Curry, Cleven, and Sears. Identification, the importance of understanding what is that you are identifying, what's the causal effect for whom, it's something that has been increasing in economics since the 80s until nowadays. So nowadays, more than 50% of papers in applied microeconomics focus on identification. So identification is something really important and something that has been clearly changed by the work of these Nobel laureates. Okay, so the last thing I wanted to talk about is so far I have been talking about the power of these researchers in being clear about what's the source of variation, the source of identification when thinking about causal effects. So the tools were there. The idea here was to think about, okay, we have the tools, we have this kind of methods. Let's try to use natural experiments to see whether it makes more sense or not to think about these assumptions. And of course, there was the development of the late framework, which essentially changed the way that we think about not just interpreting the results from natural experiments, but also how to give interpretation of randomized controlled trials with imperfect compliance. But not only research has changed, what this work has changed as well is the way econometrics is taught. For instance, in 2008, the year I obtained my PhD, this book was published, mostly harness econometrics. At this same year, I started teaching econometrics, and this, together with Cameron Trivedi, was one of the books that I used to teach in econometrics at the graduate level. This was super refreshing. This was the idea of like trying to, it just covered the mismatch between reading papers that you had in the reading list and econometrics, standard econometric textbooks. So this is kind of like a very, very important book, which I think has changed the way grad students approach economic questions and the way researchers do think about causality nowadays. Not only that, but there is also this book by the same authors, Joshua Angris and Stephen Pishkin, Mastering Metrics. And again, this was published in 2014, and the flavor here is more for undergraduates. And I think that, again, it's changing the way econometrics is being taught. And indeed, at the University of Exeter, I teach a module that basically was inspired by all this research and all these methods and all this way about thinking about causality in economics. And it's a model that I teach in the third year. And I'm sure many people are trying to do the same thing or doing the same thing around, because it's a way to make sure that students get involved with the notion of causality and the way that empirical research is being done in economics. So just like as kind of a summary of what I think basically this 2021 Nobel in Economics is about. So I think that these researchers, David Carr, Josh Angris, Guido Imbens, and the late Alan Kruger, they ask and answer very, very important questions. They use existing methods, exploiting natural experiments. So the focus was on the design, trying to understand why some individuals have more schooling than others, why some people are affected by the minimum wage and not others, trying to understand what is driving this selection. At the same time, they developed new frameworks to give an interpretation to these findings. And as you can see, like the work by Imbens and Angris was motivated by two of the studies of Josh Angris, one with Alan Kruger, the one on the quarter of birth, but also on his work on the impact of what's the impact of veteran status on earnings by using the Vietnam lottery draft in the US. So basically the idea was try to understand what are these instrumental variables telling us and for whom. And the last two bullet points, and I think these are very important. I think that the work of these giants illustrates something which is fundamental and sometimes it's not clear. But I think that the whole point here is that causal inference relies on assumptions. And the crucial point is try to understand whether these assumptions are plausible or not. Many of these assumptions are not gonna be testable, but you can investigate them. You can try to see whether they are plausible. You need to get a clear understanding about the context in which you are conducting your research and your investigation, and try to implement what they call refutability or placebo test to try to see whether basically they are sensible things to assume or not. And this is a change in the paradigm of the way empirical research was done in the late 80s and the way that they changed the way of thinking about doing causal inference. And yeah, so this is basically what I wanted to discuss today, and it's the summary of this year's Nobel in economics. And here there is a bunch of references. It's kind of like the main ones that I use for this presentation. Thank you.
Outstanding. Thank you very much, Climent. While we are, yes, if you could, there's a reactions button down the bottom. If you could just put in your favorite reaction, let's shower Climent in various things. That was fantastic. That was really, really interesting. Thank you very much for that. While I think of it, I'm going to stop the recording now. The recording of the presentation will be made available, but I'm not going to record the questions. That's stopping now.